Hi there. Good afternoon. Well, good morning, good afternoon, and good evening. I wanted to create this lecture recording on the concept of a data structure called trees. Right? Trees is one of those that is not very commonly used, but it's important to understand how it is implemented, and also, if you're wondering, a tree data structure, where is it used? And you can imagine, most of us have a map, some kind of map app on the phone. When you look for directions, routes on the phone, it definitely uses some kind of tree structure, I would believe so, to figure out what's the shortest path, direction wise. So normally tree has a couple of attributes that you want to understand, right? The first one, normally in a circle we have something called a node, right? And then you have edges, right? And then you have B, C here. Okay. In most cases, anything on any node that's above another node is called a parent node. Parent node. This one could be a child node, right? Child node, right? That child node can have other nodes, which can also known as C, D, E. Let me make this E, F, and G, right? So this could be leaf nodes, also sometimes call it leaf nodes, right? Various things, and edges is right here. These are nodes. These are also nodes. All of those are basically nodes and edges. That makes a tree. Now, in most cases, when we visualize a tree, we visualize it in this triangular formation, right? But however, a tree can be also like this, A here, B, C, D, E, F. That's also a tree. Regardless of how you put it together, there's still a tree because it has nodes and edges that's joining it together. One of the concepts that we will learn in this lecture is the whole idea of how do we go about in Python, how do we go about creating a tree, right? How do we create a tree? Python does not have a built-in tree structure that you can use, right? So you have to basically write code to create it. And the way it's done simply is, normally you would have create a class. You can create a class, and in that class you have two variables kind of thing that points to a class of the same type. Okay, the class will have a data, and this would be a pointer to the left, this is a pointer to the right, and then this would be pointing to the same data type of a class. And this would also have two variables in it that will point to another two class objects. So when we code this, you will understand how this could be implemented in Python. But even when we're implementing writing code in Python to create a stack, you can use a class stack, right? And queue, anything, right? You can do a lot of things using classes. And linked list, linked list is you might have seen my other lecture on linked list, right? Same concept. The only difference here is that you have an extra I want to say pointer, extra node that will point to another node. So that's the only difference between linked list and a tree structure, right? But when we code, you'll see how it is done. So the other piece that I don't want to miss, at least for now, that you really need to understand in terms of your learning. So let's just say we have a tree. A, right? I got a B, right? I have a C here. And then I also have a D and an E, right? E. And then I have an F. And then I have a G. Got it? Okay, so whenever you have a tree, there are methods to traverse or traversal through the tree. Basically, the idea of traversal is how do we go about making sure that all the nodes are visited and recorded, right? That's what traversal is. When we're looking at trees, especially this binary tree, there are three methods, three ways. One is called the preorder. Okay, preorder traversal. And preorder is pretty cool because in preorder, what happens, when you want to go through the tree, right? You make sure all are visited. right? You're going to start with the root, with the root node, right? This is the root node. I'm going to call it root. You will start at the root node, and then either you go to the right or the left subtree, right? Basically, that's what it recursively, you go to the left subtree or the right subtree. In most cases, we just go to the left. So recursively, you from A, you will go to the B, right? And from B, recursively, you're going to go to the next subtree. And whenever you're done with visiting all the left subtree, you're going to go to the right subtree, right? And then right subtree right here, right? As soon as so here's the thing, as soon as you come to a root node, because that is a root node right here, that becomes the root node, that becomes the root node. As soon as you come to a root node, you go to the left side, right? And then once then you go to the right side. So that is how basic way to visit or traverse all the nodes of a tree, right? You have to check, to complete one side and then do the other one. So in preorder, what happens is that how do we traverse it, right? In preorder, you visit the node first, right? You visit the node first. I'm going to start with A. So my A is going to come right here. As soon as you visit a node, you record it. From A, I'm going to go to B. As soon as I go to B, I'm going to record B right here. Oh, wrong one. Right? From B, I'm going to go D, right? Then that would be a D, right? And from D, I cannot go any further. So I'm going to go back to B. B is visited already. Then I'm going to go to F, right? So that means I'm going to have F right here. And then from F, since there is nothing else after F, I'm going to go to B. I'm going to go back to A. From A, I'm going to go to C. So now I'm going to put a C here. And from C, right, I'm going to F. And after F, I'm going to go to G, right? So I'm just taking a shortcut right there. So that'd be F, A, B. Oh, no, this is E. I'm sorry. This is E, right? So that's E, C, F, and G, right? So the traversal would be, right? You can put sometimes they put arrow here too. A, B, D, E, C, missing F here, missing F. That's what happens when you take shortcuts. F and G. Running out of space, I can move the window to that. So that's preorder, right? As soon as you start with the node, you record, and then you move. You visit the node, you move to the left subtree, and record it again, and do the same thing. So that is preorder. Now the other one that we also the other method of traversing a tree is called a post order, right? Post. So that would be post order, right? The way post works is kind of it's almost opposite the preorder. So I'm going to take all of these errors out, right? I'm going to take all these errors out, and let's see how we can make that possible, right? So in post order, the root node is visited last. All right, the root node is visited last. So what that means is that I'm going to start with the A, but I'm not visiting A, right? I'm going to start with the A. I'm going to go to B because it's a root node. Now B is a root node. I'm not visiting B at all, right? Because it's a root node. And the post order, the rules of post order is to visit the root node at the end. So from B, I'm going to go to D, right? Now D does not have any child, so I'm going to visit D. So D starts here first, D, right? And then from D, I'm going to go back to B, and I'm going to E. E does not have any child, so I'm going to visit E, right? Visit E right here. Arrow. Now from E, I'm going to go back to B, right? Going back to B. So now I'm going to visit B, right? Now I'm going to visit B because B in post order, you visit the root node at the end. So now E would take me to a B, right? And from B, I'm going to go to A. Now, do I visit A now? I don't, because A still has some child that is not visited. So even though I'm going back from B to A, I'm going to go to C, right? C is also a root node. I cannot visit root node yet. I need to go to F. Okay, I need to go to F. F doesn't have any other child in it. So I'm going to visit F, right? F, go back to C. Can I visit C yet? Not yet, because C has other child that is not visited yet. So I'm going to go from here to G. Okay, visit G already, right? Because G doesn't have anything. Then I'm going to go back to C. And now that I've visited all the child of C, I'm going to visit C, and I'm going to go back to A. And now that I've visited all the child of A, then I'm going to visit A. So basically the whole idea is, so from B, we went to A to C, C to F. So I'm going to visit F, right? And then I'm going to visit G, right? We've seen G, okay. G, and then coming up to C, and then come up to A, right? So that's basically a post order. Post order is simply you visit the root node when there is no child left, or when the child has been visited, right? So that's the basic idea of a what is it called? Post order, right? You can see how post order and pre-order is different. I'm trying to take all this yellow out so I can use this for this other method that we have also. All right, D, E. Okay, the other type of traversal that's out there that's fairly common to use is also that is called in order, right? So you got pre-order, post-order, and you have in order. In order traversal. Now the way in order works is that what you do, right, in the in order, all right, you visit the leftmost node, recursively visit all the leftmost tree, right, the node, and then after you visited the node, the leaf node, then you visit the parent node, the root node. Okay, so let me walk you through. I'm going to start with A. All right, start with A. Actually, I'm not visiting A yet, but I'm going to start here. Right, start with A. From A, I can go to B. Right, so I'm going to go to B. But according to the rule, I'm not supposed to visit this yet. Right, so what I'm going to do after I have visited, as soon as I reach B, I'm going to go to D. Right, now D is a root node that doesn't have any child in it. So I'm going to visit D. From D, I'm going to go back to B, right? In order traversal means I'm going to visit B now. Right, from B, I'm going to come down to E. Since E doesn't have any child, I'm going to visit E, right? And then watch what happens. From E, I'm going to go back to B, right? And go back to A. So since I started with A, right, now I'm going back to A, I'm going to visit A. Right, I'm going to visit A, right? And then I'm going to go to C, from C to F, right? So F would come here, right? From F, I'm going to go back to C, C would come here, and from C, I'm going to go to a G, right? And all of it is done. So remember, these three methods, pre-order, post-order, and in-order, number 3, these are the traversal methods that we use. So once we write code, you will see, how these all come into play, how things are different because of the way we call the recursive method. All right, so I'm going to close this. Hopefully this makes some sense on pre-order, post-order, and in-order. Okay, when we write code, maybe that'll make more sense to you. So, all right, bring a window here, and then I'm going to open my my Python compiler. I'm Python IDLE. So you remember when I was drawing those boxes, right? Those classes that would represent a tree node. So that's the first thing we've got to do. So I'm going to say new file and go ahead and save this window as a desktop. What is this? A tree, right? Tree. All right. So first thing first, I need to create a class that will be that node, right? Or the box that I drew. Remember the box that I drew? So I'm going to put here. This would be my, this would be a root node. I mean, not root node. This would be a node, right? A tree node rather. Let's put it as a tree node, right? And basically, you're going to say class node. Have a function here. And this function is a constructor. Constructor basically takes self and also takes some kind of data. All right, I'm not sure what data you want to call it. Let's just call it constructor takes a, what do you want to call it? Data? Yeah, let's just call data. Right? And then, so here also, so remember one thing, each of this node, they have a variable where data would be kept. Data could be anything. We haven't decided yet, but it will have other two variables also that will be a pointer type of thing to the left node. I can set it to none, right? And self dot right. These two pointers would be pointing to the child nodes, right? And then self dot data is equal to data, right? That is it. All right, and then so basically that's it, right? That I have my my node, right? And also I can also create another function and call this define, and I'm going to say print, or maybe yeah, print data. Maybe data is okay. Print data, and here this method takes a self and basically do a print self to data. So nothing fancy yet, right? Just two functions. One is the constructor taking some data inside, and then the other one is a function that will print the tree out. All right. So okay, now I'm going to basically let me create say root node data. Let's put 50 here. Let's put 50 here. All right, and then I'm going to say root node dot print data, right? So that should basically print me a 50. Very cool. So that is there, right? Now we want to write a function. Now we have the tree. We have the tree. You can call it the leaves or the nodes set up, right? We have it set up. Now I want to go ahead and write a function that will allow me to add nodes to it, right? Like a child node or like a leaf node to it. So okay, let's in here. Okay, how do I do this, right? So a couple of ways you got to do this. So now I'm going to say define insert. All right, and of course you have to have, this would be insert node, self definitely, and of course data, right? Some kind of data coming in. Okay, so first thing I want to check, you want to check if data has a value, right? If it's valid. So I can do here, I can say if self dot data, right? So check that first, and then right, if it's valid, then I'm going to go and do a self, if self dot left is none. That means if the left node is empty, then I'm going to create one, self dot left, right, is equals to node data, right? I'm creating one. So I'm basically checking if the left node is empty, then I'm going to create one. Else, right, if the left node is not empty, that means the right, that means no, if the left is not empty, all right, left is not null, not none, that means I can go ahead and do a self dot left dot insert node, and that's going to take the data, right? Okay, so they'll take care of that. If it is so insert that node, and then you can also you can check on the right side elif, check on the right side elif data is greater than self dot data, right? That means I'm going to set this to the right side. If self dot right is none, check that none, then basically you're going to say self dot right is equals to node data, right? And then basically that's that. If else self dot right dot insert node data, right? Fairly straightforward. And then so that is cool, right? Then elif, I'm gonna put this here and say else, another else needs to go here. Right, so now let's see what happens. In order for me to insert a node, okay, first thing I want to check if the data is the data that's coming into me to insert, if it's valid, right? If it's got some value in there, all right. And then if you know the data is valid, then I'm going to see if the node that I'm working with, right? If the root node that I'm working with currently, if it has a left, I want to say pointer, but a left class that is empty. If it is, go ahead and create one, right? Create one, right? And if it is not empty, go ahead and recursively call this method, right? On the left node, okay? Likewise, I'm also checking if the data coming in is greater than self.data, right? That means is greater. So I'm going to check if I need to insert it on the right side, check if the right node is empty, right? When I say empty, I mean it's none. If it is empty, then you go ahead and create a node, all right? Create a node, and then and if it is not empty, not null, then you go ahead and call insert node method recursively on that right node, right? So recursively calling the same method again until it is done. And at the end, what will happen is that if none of these is correct, right? None of this is correct, then basically you go ahead and self.data set the data value coming in, right? So what we want to do is I want to go ahead and run some of this function and see what it does. Now, there's many other ways you can also insert data into in a tree, but this is one way, right? One way that I've done in the past, other classes that I've taught, this is one way. Okay, so then I'm going to say here root node dot insert data insert node, right? 45. And then basically you can go root dot in data. Okay, let's just see what comes up in the end, right? Why is there red here? All right, I have if is none, go ahead and set it up, right? Create a valid node, and then else all right, made a mistake earlier, right? My elif needs to be it was tabbed, indented wrongly, so it needs to be on the left side. So that is good. Okay, so since I've inserted some data here, what I want to do next is that I want to go about okay, print data would only give me this data, which is something that I don't want. I basically want to go ahead and print the whole tree. So let me create a function here. I'm going to call this define print tree, right? And that will take a self, and on here basically I'm going to say if self dot left, right? That is, if there's something on the left, then I'm going to self dot left dot print tree, and in here, right, I'm going to print the tree, and then also self to data, right? And then that's the left side. I also got to do the right side. So if self dot write RIGHT, then self dot write dot print tree, right? So now that will hopefully print the tree for me. So instead of print data, I can go ahead and print the tree, right? And this will hopefully give me a good, you see that? It's printing the tree as I want it to be. You know, I have an extra print here, which is kind of throwing things out. So I'm going to comment that line of code out. All right, let's just see if it's printing the tree as it's supposed to be. Okay, 35, 65, 45. So you got 35, 65, 40, 50. Okay, that's good. Okay, so now that we have done that, right, fairly straightforward stuff. Now I want to show you about writing a code that will do a in order, actually post, no, pre. Let's do the pre-order first. Pre-order is simpler, right? It's simpler to understand. So in order to do a pre-order traversal, right, I'm going to say define pre-order traversal. Hopefully the spelling is correct. I'm not sure. Self, and then also it needs to have the root node, right? And then, okay, we can do it a couple of ways, right? We can do it a couple of ways. You can use a, I wonder if we can use a list here to do a, yeah, I guess we can use a list. So I can say result. Let's just pull in a list. Let's just use a list to capture, you know, the nodes we're visiting, right? Pre-order. So here I'm going to check if root node is valid. Very important check though. If root node is valid, then I'm going to say list dot, actually not list. Let's just put visitor, right? Visitor dot append. Right? Because in pre-order, as soon as you reach a node, you visit it, right? You visit right away. So that would be listed, would be that. And then I can simply say visited, spelling not coming to me, equals to traversal, right? And this will take me root node dot left, right? And also, since I need to copy this whole thing down here, I can put the visited to the root node dot right. All right. So according to what we have done before, all right. Right, according to what we have done before, pre-order, right? Pre-order, and that's what's happening. In each of these traversal methods, you recursively visit each node, right? And in pre-order, as soon as you visit, you print it out, right? So basically, as soon as I visit a node, I'm gonna add it to my list. Okay, I'm gonna add it to my list right away. Okay, so that's how it is done. I'm gonna add it to my list. And as I visit the other ones, I will continue adding it to the list. So now you watch, when I do a print tree, I don't have to do a print tree, but I'm going to do a pre-order traversal. I'm not going to get the spelling correct here. Right, so run this one and see if it does print what it needs to do. Oh, you know, it's not printing it out. So I can simply print this out right here, and now it should. Right, prints it out. So you see, ask yourself if that is correct, because what happens here is that in our tree, the first node we added was 50, right? 50, and then 45 is a child, right? 65 is a child, and 35 is a child. So as soon as it visits 50, it prints it out, then 45 and 65, 35. So you can see the order being maintained, right? The order is maintained. Likewise, when you want to do a post traversal, now watch what I'm going to do. I'm going to cheat a little bit here. Post traversal is exactly the same thing, right? Of course, it's not called, well, so much for my cheating, you know, because now, oh no, I think it's still, the indentation needs to be correct, because if not, it's going to post order. All right, post order, everything is pretty much the same. The only thing that happens is this append, right? That append happens at the end, right? In the post order, the append happens right, because you're starting with the left, so you have to do a self post order. Make sure I change these ones. Change that one too. You know, every time I copy and paste, I've definitely missed something. So hopefully I'm not making the mistake here too. All right, in post order, right? How does it work? Post order, basically, you visit all the child of a node, then you visit the node, right? So here I'm going to start with the left node, right? Visit the left node, and then visit the right node, and then the root node, right? The root node. So that is how basically it's done. So I'm going to print that out as well. Here, instead of pre-order, I'm going to do a post order. What happened? Did I copy and paste and miss something up? That's what happens when I. Alrighty. Almost not worth to copy and paste. Right? You see, it prints it out, and you can see the order it printed out. You see this? This is what we had before, which is the pre-order, right? And this is the post order. Okay, post order. And now what I'm going to do is that I'm going to go ahead and use the same code to do my in order. In order is very similar to what we have here on the pre-order as well. The only difference is that you are visiting the node in the middle. So in order, and then this append needs to come out from there. And that append needs to go right here. All right. And basically that is what, and of course, this is, since you don't have one, you don't have a visited ready yet, right? You haven't gone anything yet. So you need to take that out now. Now that should be good, basically, right? So visit the left side, right? And then visit the root node, and then visit the right side. That is your in order compared to pre-order, post-order. There's a different variation between all of them, and I'm hoping you guys can all see it. So now what I'm going to do, I'm going to run all of these, right? I wanna do 3 of them here. Pre-order and in order, right? Let's just see what comes up to be the outcome. See that? Right, little variation of what you see as the outcome. So those are the things you need to understand as you are working with the tree. Now let me see if I'm missing something else. I don't think I'm missing anything else. You know, this is a fairly good introduction, and yeah, the only thing you have to well, try it and see how it turns out. Anyways, good luck, and have a wonderful day.